Okay, let's talk about Floyd-Warshall algorithm. What does Floyd-Warshall algorithm do? It detects all pairs shortest path. What is all pairs shortest path in a graph? Suppose this is A, B, C, D, E. Let's add F. Okay. Let's make some random path. Okay. Now assign some weight, like from A to F I need to walk 5 step, 2 step, 3 step, D to E less like 1 step to make it more 1. Now from A to B, what is the shortest path? A to B, there are 2 paths, A to F, F to B. What is the shortest? A to F. So A to B, let's make it a directed graph. Okay. I think it looks more beautiful. So A to B, if we take the root via F, then it will be 7. But A to B is 1. Okay. From B to A, what is the least path? There is no path. 0. No, we assign is like not 0, we assign infinity. Okay, because no path. Infinite distance. A to D. What is the shortest path? A to F, F to D. 5, 3, 8. So A to D, 8. Like, so similarly A to all other, and so all pairs, all possible pairs, shortest path. So we understood what does it do. Now where can we use it? Floyd-Warshall algorithm, it works on both directed graph and undirected graph with weighted edges. So it works on both directed weighted graph and undirected weighted graph. But where it will not work? If there is a negative cycle, Floyd-Warshall algorithm will not work. what does negative cycle means? Like from A, B, C. Okay. Suppose from A to B we minus 5. So we suppose from A to B we lose our energy minus 5. B to C minus 3. From C to A plus 6. So from A to B we lose our we lose something, like we lose our money minus 5. So we lose 5 money. From B to C we lose 3 money, so minus 3. From C to A we get plus 6 money. So from traveling A to A via B, so A, then B, then C, then again A. What is the total cost? Minus 5 minus 3 plus 6. So minus 8 plus 6 equal minus 2. Okay, this is one cycle, first cycle. In the second cycle, we already have minus 2 accumulated in A. Already have minus 2. So this is our head start with minus 2. Again, minus 5 minus 3 plus 6 again equal minus 2. Minus 2 minus 2 equal what? Minus 4. So for third cycle we get minus 6. So this is a negative wise cycle and it goes indefinitely and the cycle never ends. So we actually cannot detect all pairs shortest path in this case because it is indefinitely going. So the actual value is not found. However, we can detect if there is a negative cycle using Floyd-Warshall algorithm, because from A to A, if we get the value from A to A pair, we get minus 2. So there is a negative cycle. So we can detect negative cycle using Floyd-Warshall algorithm. Now, how to implement this algorithm? What is the basic intuition? Like from A to C, there is a middle part B. Now, like from A to C, the cost is 8. From A to B to C 1. So, A to C equal 8. And then AB plus BC equal what? 3. So if A via B to C is less than A to C, then what is the next part? B. So A to B, then B to C is our path towards A to C. So we prefer A to C. And we do this for all possible pairs via all possible middle value. So what is the algorithm actually? Let's make some ground. Let's infinity equal n 10 to the power 5. We use Python put source equal G, destination equal, we use, what is this, destination 3, and this is our graph 0 1 2 3. This is the given graph. We first the graph given in adjacency matrix structure 0 3, infinite equal 10 to the power 5. It just taken a large value. I think it's large enough, so take infinity because 7. So from 0 to 0, the distance is 0 because we are already in 0. From 0 to 1, the distance is 3. 0 to 2, there is no path. Okay. We are not talking about, we are only talking about neighbor. Okay. From 0 to 2, there is no direct connection between 0 to 2. So initially it is infinite. From 0 to 3, 7. We are not talking about path, we are talking about neighbor. So 0 to 2, no directed as, so it's infinite. But there is a path from 0 to 2 if you take by 1, but initially it is infinite. This is the given graph. This is our graph. So we make a copy graph. That is our output. So distance dot distance equal graph dot copy. We will not modify the given graph. Distances we will copy. Shallow copy. Now there is a next matrix for storing the next path, like from 0 to from 0 to 2, the next path we will choose is 1. Okay, so from 0 to 2 the next path is 1. So from 0 to 2, 0 1 2, the next path is 1. Okay, initially we declare every value as -1 and then we will modify it. So how to declare -1 for I in range B, again for J in range B. What is B? B is the number of vertex. Okay, so this will create a B cross B matrix or B cross B to the array. Okay, you see next. Now how to make it next value for I in range B, for j in range B. Initially, there is no path between I to j. So if graph I to j equal infinite, so it remains as -1. Initially we think it is as -1 because there is no negative weight. We initially think next equal -1. We think there is no, is there any s identity -1? No, there is no s called minus, sorry, there is no vertex called -1. So next ij equal -1. And if there is a path like direct path, graph ij, there is a direct path. If like else, okay, else next I to j equal. So what is the path I to j? What is the next path of I from I? What is the next path? J. Next I to j equal j. Okay. We modify this eventually while running Floyd-Warshall Algorithm. So we have made preparation for our next. What is, and now we see the main algorithm. That's Floyd-Warshall algorithm. This is the main Floyd-Warshall algorithm. Okay. We see main algorithm. Here for intermediate value k in range V, for starting I via k via j. I in range V, or j in range V. These number of vertex. Okay. If distance, what is distance? Distance is also same as the given graph distance, but it is a shear of, okay, we will update only distance. Distance I to k equal infinite. Like if we want to travel I to j, but I to k there is no path, so we will disregard it. Okay, or k to j there is no path, like I to, so if I to k there is a path, but k to j there is no path, so we cannot travel using k, so just disregard it. How to disregard? We will see. Distance k to j equal infinite. Infinite means there is no path. Okay, so continue means just ignore. If distance I to k plus distance k to j, okay, is less than distance I to j, so what is the distance of I to j? Is I to k plus k to j. So we update the distance of I to j. So what is the now the shortest path between I to j? It is I to k plus k to j. So I to j equal distance I to k plus distance k to j. Okay. And you can see I to j. From I we could travel j. Okay, it was the next value. But here next, when k is chosen as the next path from I to k, so what is the next path? I to k to travel j. So next I to j equal path. Next I to k. Why we are using I to k instead of k? Because this is a dynamic algorithm using tabulation method. So I to k is shorter than traveling I to j. So if you take a route via k, it is shorter. But there may be a path m. So I to m, m to k is also shorter than I to k. So then we have to travel I to m, I, m, k, j. So what is the next value of I? M. So this is the I to k next value, I to m, and so next I to j equal next I to k. Is it visible? Yeah. So we found distance, we found what is the next path we should take to travel. So our algorithm is completed. So we have found that the all here shortest path, which is the distance. So print distance is the output. Now there are some additional values we want. Like we found the shortest paths. We found the all pair shortest path. We call it distance. Now what is the actual path? Like A to B, then C. So we know A to C, the path is A, B, C. How can we print A, B, C? Okay, we use next matrix. How to find next matrix? Initially we declare a path. If next I to j equal -1, -1 means there is no path from I to j. So A to C -1. That means there is no connection between A to C, via middle or direct. No connection. So print no path. Done. Else path dot append, we convert it into string because it's more easy. Source. Initially the source is added to the path because A added to source. Okay, while we will use a while loop. Source not equal destination source समान equal max source destination. So we update the source value. So first the source pointer was here, next source